that could be useful back here on Earth. Now, from your perspective, what's been a particularly interesting project from that end of things, and how do you think that could then potentially help us with healthcare issues back here on Earth?
Well, I think the stem cell studies that we're looking at can be of potential benefit either by understanding why those cells grow better here in space and being able to replicate those conditions on the ground, or my vision is that we would produce stem cells on Axiom Station.
That would be fantastic, and I think could be potentially transformative for lots of different applications for understanding diseases and potentially developing new therapeutics here on the Earth. So, Peggy, I know you've also been doing some technology demonstrations this week, particularly for Axiom ourselves, so we can learn how we can do things in space in future. So, what kinds of technology demonstrations have you been doing on that front?
Well, we've been looking at kind of an inventory system that uses visuals rather than other sensors, types of sensors. We've also looked at comm demonstrations to try and improve our access to communications on board using basically a Teams-like version of a connection and some other using our tablets and sending down our information directly to the ground to try and see if we can speed up the process of getting pictures and photos out. There are just so many that we need a quick process.
Absolutely. And that sounds like quite a lot of fun to be doing some of those tech demos while you're up there as well. So I'd love next to ask some questions from the other members of the crew. So I'll start with John, if that's okay. So John, I know you've been our STEAM hero this week. So science, technology, engineering, art, and mathematics, and doing lots of activities on orbit and clearly having a blast this week. So can you tell us about how some of those activities are helping teachers down here on Earth maybe develop new kinds of lesson plans or curricula that could help students understand a bit more about space?
Sure. And, greetings, Dr. Lowe. It's a pleasure to be here. Actually, this week has really opened my eyes to the benefits of how talking to young people and getting them to step forward and express the vision of themselves. It has been astounding to me, and my hope is that teachers and other educators and even parents see this also, that every student has some story in them that they quietly believe in themselves, and we should encourage that to come forward. So, that whether it's talking to the students like I have this week, or the art contests that we produced here on orbit with 26 countries involved, over 900 students, there's clearly a lot of energy out there for space that is exciting for children, and I hope the educators and parents see that.
That's fantastic. And thank you so much for all of that work to inspire new generations of scientists and engineers. So you've been doing some different kinds of recordings on different physical phenomena, I think, this week as well. Which have been the ones that you've particularly had the most fun with as you've been making those videos?
Well, we've done a range of those. We call it Living in Space, and the effort there was to produce a short set of curriculum supplements to be used in classrooms that teachers could then, create a conversation with. But the concept of living in space was to allow a young person to contrast how they live on Earth to what living in space would be like. So whether it's how you keep your sock drawer in order to how you go to the bathroom or feed yourself, and also some physics experiments so they can see the physical representations that microgravity have that are both mystifying and very fun, actually, as an astronaut, that they can enjoy and look forward to. So for me, it's hearing the little screams and yells in the background when we have some of these events, and I look forward to sharing the recordings with them when we come back.
That sounds like so much fun. I can't wait to see some of those videos. So you're quite an adventurer here on Earth and now in space as well. So have you learned about some of the experiments that are happening on AX-2 that can help us understand how humans adapt to spaceflight? And also, do you think all of the adventurous things you did on Earth in advance have actually helped prepare you for space?
Well, we could talk all day on both of those. So the easy one, yeah, absolutely. And I learned this during the process of training for this mission that a lot of the things in training were, uh, either new or very familiar to me that I had done a lot of this before in some other fashion. So everything I've done in my life, in one way or the other, that particular event has prepared me in some way for this. And I really think that that goes back to the vision I had of myself when I was younger. That even though I didn't become an astronaut at the time, every step I took, every activity I engaged in was something that would prepare me for this. So that's been very encouraging. And the science that we're doing, one in particular for MIT, the skin suits, was a project, by MIT Media Labs, which was the effects of gravity, low gravity mitigation suit, anti-gravity or low gravity countermeasure suit, and that is to help the physiology remain adapted to a 1G environment so that travelers coming back from space would have an easier time adapting, and perhaps even be able to exercise a little less if they can maintain the effect of gravity. So we're collecting data. In fact, I have another session immediately after this call, and hopefully MIT will bring us back some good intelligence on that and show us the way forward to spaceflight.
Fantastic. Well, we definitely shan't keep you from donning that skin suit again and doing that next set of experiments for MIT. So next, I'd love to move on to Ali, Mission Specialist Ali Al-Khani, and ask him about his work. So Ali, you have also been busy this week with lots of STEAM experiments as well for students across Saudi Arabia. Can you tell us what you've been doing? I hear that it's involved fireworks and kites and heating things up, and all this kind of sounds like lots of fun science to me.
Well, it's always great to hear from you, Lucy. During this mission, we've been working on a different number of experiments. One of them is a major point of focus for me, which is the cloud seeding, because in Saudi Arabia we want to fight the certification. So with the results of this experiment, it's gonna enable us to develop new technologies in the future, and that could help us to increase the effectiveness of artificial raining to more than 50%, which is great for any country with low rain volume, and it's going to be beneficial and helpful. And also, we've been doing a lot of outreach, which is educational and awareness experiments with the school kids, which was a lot of fun for us and for them for sure. We've been doing space kites and liquid fireworks, and also we have one more that's going to happen tomorrow, which is the heat transfer experiment.
Fantastic. So it sounds like you've been inspiring new generations of researchers and explorers, and also doing lots of work for not only for how we can improve agriculture on Earth, but I think also potentially for some exploratory experiments for maybe agriculture on the Moon and Mars as well, which is really exciting. So I saw that you also posted a picture of yourself wearing an EEG cap or an electroencephalography cap the other day. So you've clearly been taking part in some experiments looking at brain function while you've been up there. So what kind of activities did you have to do while you were wearing that cap? Did you have questionnaires or did you have tasks that you had to do? What did that look like?
Well, I slept. No, I'm I'm joking. So there are a lot of things to look at and do as well, as basic as finger tappings and reading scripts on the screen, or just focusing on a visual demonstration illusions that gonna be displayed, and just keep looking at them as the cap reads your brain, basically.
That's fantastic. Well, thank you so much for taking part in those kinds of studies. It's really interesting for us all to learn about that. Now, I'm going to move on to our mission specialist, Rayanna Barnawi, as well, about what she's been up to this week. So, Rayanna, you have spent a lot of time in the life science glove box this week, so you must be a pro by now. So, what experiments have you been doing in there, and which ones have you enjoyed the most?
Thank you so much, Lucy. It was really amazing to be able to compare working on samples and cells on ground versus here in the LSG. So, to me, just starting with the DNA nanoparticles, it was an amazing experiment that has so much complications in it that makes it a little bit interesting to me. And then after that, we were able to start on the RNA response experiment and the stellar stem cell experiment. So for me, it was a joyful week full of research and science inside the glove box.
Fantastic, and thank you for all your hard work in there. So you talked a bit about the DNA-inspired nanomaterials project. And so this is a project that is looking at some really cool nanomaterials that are based on the structure of DNA, and they self-assemble. And there's lots of excitement down here on Earth because they could potentially be used to deliver new drugs and therapies to humans in future, and could also be used as maybe scaffolding for degenerating joints. So what were the actual procedures that you were doing in the glove box? And could you see anything happening while you were doing it? Could you see these molecules actually self-assembling while you were working in the glove box?
Yes, indeed. It's a very interesting experiment that involves a lot of materials and mixing them with like protein and seeing how that affects the shape or the viscosity of the liquid that we are mixing with. And for me, just trying to see how the shapes starting to form by making the water a little bit turbid. It is very fascinating and interesting, and I was hoping I could see something like by microscopic way or some sort of formation that would enlighten us a little bit more. But it was very interesting and very exciting.
Fantastic. And so you're obviously trained as a researcher yourself, and you've worked on stem cells here on Earth. So I know you've been doing lots of work for the Stellar Stem Cells project this week. So what have you been doing in the glove box with these stem cells? Have you been feeding them? Have you been growing them? Have you been looking at how they respond? What's been going on with that project?
Well, that project is very interesting because me and Peggy keep fighting over who's gonna do the experiment first. Well, for us, it's been very interesting because we were able to grow the cells and make them adhere to the plastic, and then being able to visualize how they look like in the microscope in the Kermit. It has been really interesting to see how they develop and changing media and doing some transfictions on it, and seeing the effect was really amazing.
Fantastic. And final question for you, Ray, is what kinds of techniques or methods have you learned about in space that you want to come back and try here on Earth with the next set of your research studies?
Well, first of all, I'm very thankful and grateful for all the scientists and researchers who believed in us and sent their research with us so that we can help them do the research here on board station in this micro gravity environment. I would say that this sort of environment helps us understand how the cells behave and how the media behaves. And then once we are back, we would help work with the experiment developers on Earth to develop the methods and the protocols in a way that makes it a little bit more efficient and get to better results, of course.
Fabulous.
I have a funny story to add. Ray was working in the MS or in the LSG, the glove box. She had her hands in there. She was doing something very complicated, trying to put these plates that have open wells on them. They don't, and so she has a lid on them. She's trying to slide them in, and I'm like, just turn it over. And she's like, no, it gives me a heart attack. I'm like, it won't come out. It's zero gravity.
They're already sideways, but my friend
That's fantastic. Yes, I can imagine that working in a zero-G glove box can be quite disconcerting at times. So we're almost at the end of our time. So I wanted to thank all of you for all of your hard work that you've been taking part in this week. Lots of really interesting and fun science and technology demonstrations over the past week. So everyone here on the ground is so incredibly grateful for all of your dedication and hard work from the whole crew and everyone who's been helping. So a huge thank you from us. We also can't wait to welcome you home and see how all the results from all these cool science projects are going to be moving the needle forward in terms of how we understand ourselves, our planet, our life, our biology, and our place in the world. So thank you again to all of you on station for all your hard work this week.
Well, and we want to thank the investigators so much too, because it's their ideas that have made this science come to fruition.
Thank you so much, Peggy and the whole crew.
Station, this is
Bye-bye.
Houston ACR.
Thank you very much.
Thank you. That concludes the event.
Thank you to all the participants. For station, we'll now be resuming operational space-to-ground communications.